I want to talk to you today about rigging. And before we dive right into it, what's important is if you think about rigging, you usually have two phases, if you want it like that. You have the phase where you have maybe a few characters and you just want to work with like pre-shipped or pre-built elements. And your focus is to get that character out as quickly as possible, configure it, and animate. So that's your focus. That part will be my first part of this talk. But then you have certain cases where you need to find very specific solution or where you need to dive a little bit deeper into the rabbit hole and actually build maybe tools that even others that want to build their characters then can use. That is the more advanced part. That is the second part of my talk. So we're going to have a little bit of both, and you can see where you feel most comfortable or just enjoy all of it. So let's start and dive right into it, and let's start with a little bit of fun with tags. So here we have Electra. Electra is now with 20.5 completely rigged with pre-shipped components. So we actually added a lot more of those auto-rig components for you. So you will be able to get a lot more out of it, just out of the box. And the good thing is you can purely stay in SOPs for that. What I did throughout that presentation is that I added a bit of color coding to all the auto-rig nodes that we have and to the controls. And they always match a certain functionality that we have. So IK is always yellow, FK is always blue, and so on and so forth. And when we now just look at the nodes here, you will see you just have one yellow node. So that one yellow node seems to create all the IKs for your whole character. That brings us pretty much to another really important part that we see here, and that is that skeleton that we see here. That is not just any skeleton, that is a guide skeleton. It's pretty much a normal skeleton with a bit of additional information on it. And this additional information is tags. We know those tags from, well, so many web applications and whatnot. We use it to just put a few words on an element, and later we group and filter after that. And that allows us in so many places to be really flexible, and that allows us to be procedural when it comes to rigging. But first of all, we want to think a bit about the workflows that we usually have when we are now busy setting up our character, right? We just want to build it. First step, you need to prepare your character. So you start, obviously, with a model. And you need to have a skeleton for the character, so you set up your skeleton. When you have that, then we come to the part where we have all the colorful nodes, our auto-rig nodes. That's where the rig is being applied. And in the end, of course, you will maybe have an animator, or you test it yourself. You just test your rig with animation, and you might cycle backwards. That's really great when you have now one character. Let's say we have a polar bear. One polar bear, all cool. What happens now if we add a whole polar bear family plus a wolf? Great. How do you do that? That's not what we want. That would mean if we wouldn't have now tags, if we would just add the names always directly and they're a little bit different, it would mean that I would duplicate that big purple block, aka our rig with all those nodes, all the time over and over again. What happens now if I have a small change that I need to make to, let's say, the arms? Great, I need to duplicate all of that stuff over and over again and again. Not efficient. What we want is that. That is proceduralism. But that means that we need to be able to talk from our blue section to the purple one. So we need to prepare something before we even start rigging so that our rig setup automatically knows what to build where. And how can we do this? With tags. Tags are awesome because tags can now tell, or we can pretty much just tag certain body parts, for example, to begin with. And the rig can then ask, am I having, please find nodes that start with arm in a tag. Find leg tags. Great. If you find them, build something. If you don't find them, do nothing. And that allows more flexibility. So now we can see that whole thing in practice. So we start with the attribute just array node, go to the viewport, type in spine. That's all I had to do. Now I'm creating one of those auto-rig nodes, and I'm applying now the functionality of a spine, and I just say, please apply to everything where I have my tags. Boom. Adapted. That's all I had to do. Now I'm creating tags for a left arm and a right arm. So obviously I want to have two IKs. I'm creating now an auto-rig node that's supposed to build myself an IK. And I'm telling it here, wherever you find something that's an arm, please build an IK. And the system is now smart enough to understand that you have a left and a right IK tag group, and it just builds two IKs for each of those groups. And that's how you can be very flexible in your setup all of a sudden. So we can push this, of course, further. We have these four characters, very different in what they are. So you look at them and you might think like, this is never going to work, that we're going to put them into the same setup. They have like different numbers of legs. One has a groom, one has a trunk. But are they really that different? They actually also share a lot of stuff that they have in common. So let's have a look at those tags here. See, we all know that all of them have a spine. So we can put them in one of those body part groups. And we say that's a spine, and we can assign certain functionalities to it, like certain auto-rig functions to it. And we can now do the same for the legs, the hands, and so on and so forth. So every time we find now in our auto-rig component something that's a leg, great, I can apply a leg. If I don't find a leg, I do nothing. If I find a trunk, cool, I can build something specific for my trunk. If I don't find it, I'm not building it. If we now boil this down, that means that our setup looks now a lot more like the schematic that we had before. We have now 4 different prepared inputs. And the pink section, like the pink nodes, is just where I set my tags, right? So really just in the viewport, set a few tags. And now our little colorful setup here, where I'm layering like one task for rigging after the other in with my auto rig nodes, can now know, okay, I'm supposed to apply IK to all the legs. Great, let me find all the legs and let me build it for you. And that switch, by the way, is live. It is really that fast and that dynamic, and the rig is every time completely built from scratch. So we have that performance now for rigging as well. So now that we know that tags are great, but we can do really cool things with tags, here's my tag cheat sheet. So those are all the hardcore effects that you need if you want to build them. First of all, we have a skeleton. We need to set them somewhere. First hurdle is, what's the node name called that I need to create? Attrib adjust array. If you find that node, drop down the node under your skeleton, go to the viewport, tag away. Once you're done with that, you need to bundle all your stuff to create your character anyways, and you would do that with the pack folder node. And if you want to make your life easy, you call that skeleton with the tags just guides.scale, because all our auto-rig components usually want to have that name, so you don't need to set anything up. You can also call it waffles if you want to, but then you can also rename it on all your nodes. Okay, so we now know all the facts to set them up. Now we come to components. So our component obviously needs to find them. So please look for a parameter called segments. Those are those body parts I was talking about, right? Where do I find my arms? Where do I find my spine? That's what you set up here. And you pretty much just type in your tag, or you can even use a wildcard to make it even easier. Okay, so you also have sometimes the option, you don't need to do this. You have a few other parts. Let's say you want to have a spine, and you want that spine to be parented to a very specific control that you just created. You can, of course, also type things in there. You can always type in directly the name of your control, and you're done with it. You can also use tags for that stuff, and the syntax there is path patterns. You don't need to understand everything about path patterns. They're super cool. Look them up in the docs. I love them. You don't need to dive that deep in order to use them. All you need to know for tags is to know you need to use that percentage tag thing, put the tag in there, and you're good to go. And with that, you can even configure more on your auto-rig components. So now we've talked a lot about tags, and there's one hidden goodie that I have for you, is you can actually configure a little bit more than just tags. I mean, tags are just words that you put on a joint, right? You can also put words with a value on a joint. Let's say, for example, I put a little bit of extra information on my joint and say, like, I want that joint to be a control, and I don't just want it to be a control. It's kind of like functionality is translate control, and I want that control to have the shape of a box. And that's kind of like what we're doing here. We're adding a dictionary subnode. We're still completely in subland, and now we're saying all of these skeleton points become controls, box controls, and I'm scaling them. Now I'm applying that information that I want all of them to be controls just to a little group. That's all. And with that, you can even more fine-tune your character inputs before you go in there. That's a bit of special information. You can use it. You don't have to use it. But it's really cool because we have a lot of these like pre-shipped settings that you can set up there in order to control, well, the shape and the behavior of your controls. But you can also store there anything you like. And it will be actually on your rig as well. So now we know what you can do purely in Subland. let's now get one step further. We also, of course, want to continue with everything we've seen. And now we have the spider. And in this case, we have a very specific problem, because who wants to animate 8 legs manually the whole time? Not fun. So we want to have something that is custom, that works for our little spider, that helps us here. And now we're in that phase where we do want to know a little bit more about like how all this rigging stuff works, because we maybe want to add a little tool that others can then use to always build really cool spiders. And not just like that one spider, but many different spiders. So before we go into the details of how to set up that spider, let's think a bit about what we did with H20. With Houdini 20, we brought out Apex. Why is Apex cool? It's pretty much, it's like a Ferrari engine for your rigs. It's incredibly fast. It's really good for the viewport. And we want to have, and viewport stuff is what we want. We want to be in the viewport and set everything up there. That's of course why our rigs are like that. That's why we also added the option for you to create component scripts with Apex nodes. Because we want it to be fast, and because we want rigging, in the end, in the future, this is really one of our really important goals, is we want rigging to be interactive too. And I think you guys very likely want that as well. So in order to get there, we decided to go for that, but we're missing something. We know that a lot of people that are familiar with rigging are familiar with Python as well. Python is such a well-known syntax for any kind of little code snippet that you have. It comes with certain advantages. It's very easy to maintain, and it really helps with readability. For example, when it comes to little math expressions, when it comes to conditions and loops and all that stuff. So we sat down and thought about how can we combine these two things without losing that awesome performance advantages and that really nice format. And that's how Apex Script got created. And Apex Script isn't Python. Python is something that will always just operate on your rig, right? It can never be your rig. Apex Script can be your rig, because Apex Script is nothing but a code interface, if you want it, for your graph. And it looks like Python, which is a big advantage because it looks like object-oriented Python, which a lot of people know. So here we have one of those examples for it. Let's start right in with a very simple case to show you more what I mean. And I cannot start the video. Oh, I can. Okay. So here is an Apex Script node, and I'm now typing down a little function. The purple box here, that's actually the same as our snippet. And you can see I'm creating a node when I call a function. Really important. Every time I use a function, I'm actually adding a node. Next important thing happens is I just created a torus and I want to translate it. And I used my variable. That created a connection. So very important things now. Now, of course, we want to have our little torus that we're moving around. We want to get it as an output. We also want to control the input. We want to move that thing around, right? So we create a translate. And now we add that again to our transform to translate it around. And you can see you can directly move it around. So what we can see here and what we need to boil down is anytime you use a function, you add a node. Anytime you use a variable anywhere, you create connections. And that is incredibly helpful because creating connections in a graph can become very cumbersome. When we can just like write it down in those small snippets, it can be incredibly helpful. So to push this to a more extreme, this is a comparison. These two things here are exactly the same. So every time you type your little snippet, you get that thing as well. And now you can think a bit about like what is easier to read. If you're familiar with code, you will definitely say like, yeah, okay, the code part is. However, we know that not everyone likes code interfaces. You will have folks that will prefer nodes. The good thing is whenever you have the code, you also have the nodes. You always have both there. So you can still read that, the node part, if you want to. And of course, we want you to not write a gazillion lines of codes and work super granular. So what did we do? We added a lot of wrapper nodes. In general, we added so many additional nodes for you of all kinds of types. And we also added a lot of helpers for you. So whenever you want to do something to your rigs, like adding controls, parenting controls, putting them somewhere, coloring them, all this is now nicely and neatly wrapped up. Why am I showing you nodes? Because nodes are functions. That means for you guys, less to type. Great. So you get away with very short snippets now instead of writing like a big monument. So let's get now to something more hands-on where you can see how this works. So first of all, let's see what our plan is. We want to have that elephant trunk here to be animated with the sine curve because, well, we like the wavy motion. And in the end, we don't just want to stop there. We also have Cappy here. And we want to add a bit of a wavy, windy motion to those hair guides. And we still want to animate on top to get like that really smooth, natural-looking feel. But we still want to have our animator have control over that. So let's see what we can do in order to get there. So first of all, here's a little sine function. The function could be even simpler, believe me. But let's say we have a sine function, really cool, just a little snippet. We want that now in our rig. Let's first of all see what we have here. You see the color coding again, blue for preparing our little elephant here. Then we have the purple section. We apparently already created a few controls. Now I add my pink little node in here. That's just an auto rig node. It's nothing special, but see, that auto rig node has now a snippet section. So you can add your own little functionality and it will behave like any other component. So we'll just change your rig. So what we have down here, that's not your rig. That's the thing changing your rig. So let's now see what happens when I'm actually calling that function. So just using whoop. Yes, okay. We're calling it. And isn't that cool? It creates a little subnet for us. It just inserted that thing. Really nice. Only problem? Wrong graph. We do want it in our rig and not in the component script. What can we do? We're just not calling that thing and just adding it instead to subnet, to our rig. And now we just copied that thing over from our component script to the rig itself. That's really cool. What that means is we can actually insert expressions to our rig on the fly. And that will really enable us to be very creative with these solutions. Okay, continuing there. We, of course, want to see now how it looks when we actually do this now, step by steps. And the steps that I'm now going to show are steps you will have pretty much every time and again, and they're actually usually the same stuff. Usually, you want to have a bit of control as a rig. Then you add a control as an abstract control to control our little sinus behavior. Now it's getting interesting. You know what we just did? Add subnet. We just did that. We're just adding our little function in here, but this time 5 times because we have 5 joints on our elephant trunk. Next thing we do is we need to, of course, connect that thing up. It cannot just be floating in space in our rig. 2 little expressions, object-oriented, to do that. Still doing nothing. What are we missing? We need to set the parameters on our little function. Also, just one line that I add. Still looking a little bit weird because it's a ramp and I need to set some nice values. Ramps are amazing. They are now natively supported. You can create these little snippets with them. You can do really cool things with them. You can pretty much use them like driven keys. And you have a lot of control over it when you're using it. And you can see how interactive it is. So again, just to bring this down. Usual steps that you're going to do is like you write your truly creative piece. That's whatever you want to insert to your rig. And the next thing that you're going to do is, well, you need to add the node. You need to connect the node. And you need to set a few values. Done. It's pretty much the same thing every time you do it. So, okay, now we have the elephant trunk, but we don't want to stop there, right? We want to have our Cappy as well. So we're just switching the input, and we can see it's really cool. I can actually animate those hair guides, and I'm just using now as my starting point the hairs, but it just works on one. Not cool, so I need to adjust it. What I do now, instead of just grabbing one of those starting points, is I'm grabbing many. So I'm adjusting that part. Now I'm looping over those ones. Look at the blue box. Boom. It just popped in. And look at the viewport. Now all of a sudden, just with indenting everything in, you have the effect on all of your controls. We added a little bit of offset, but we do want to control that offset. So we're just using it as an input. We saw the same principles reapplied that we just learned. And with this, we all of a sudden changed our one tool into a different tool with just a few small modifications. And you can see how everything in the viewport directly reacts. You can, of course, look at that change down there. You don't have to. You can hide it. You can also see how your rig changes live as a graph. If you want to, you can also hide it. And now, of course, we've built up onto everything we've seen so far. By the way, we used here also tags to find all these starting points. We used auto rig components to start with. What now if you are in a case where you want to push it a bit further? What if you want to truly create your own system? This little dude here you might have seen today already. And that buddy comes from Turbulence. And they started building up their setup completely in Python. So it was a Python module. And I just went, and you can see everything here, like every step is a box in your actual rig. So it looks a bit different. And they created like a huge list of like functions that they used everywhere over and over again. A little bit like what we did with our nodes. So I sat down and said like, okay, can we go that far and translate that whole thing over as well? Yes, we can. We can do the same thing. And one important thing that you need for this is that red box up there. What this is, those are global functions. That means you write a functionality, something that you really like, that you want to have in your rig, or that you want to help to build your rig, and you just store that thing to disk as a subgraph. Remember, subgraphs are these little HDA-like things that we have for Apex? That's exactly what we're doing. As soon as that thing is saved to disk, it's a globally accessible function that you can call in any node wherever you want. And really, it's as simple as that. You just go to your Apex script node, insert your functions there, store them to disk, and you're good to go. So even more complex setups as that are completely supported if you want to go off the grid. So coming to my last very graphy slide is, of course, one thing that you might be interested in, and that is, well, we talked now about nodes being code. How do I get my nodes to be code? And that's what you can do with the decompiler. So whenever you have a graph already, or you work with somebody who prefers nodes, you can just transfer them over. And that means that you can do the same thing to your rig. That here, that is your whole rig. That's the whole Electra rig converted to code. If you want that, if you need that. You can also just pick snippets, but it opens up a few possibilities. But of course, we also want to see a few nice things that have been built with it. So here's one of the examples where I went exactly for that way. I started off with my auto rig components and the upper and lower gearing. You can see how specific that motion here is because you have the collision going on with these metal thingies. That's what I added customly. And I could even store it now as a component script. And in the end, anyone else who wants to build something like that will never see the code. And here you can even see the setup. See? Exactly what I said. I start with my normal components, my normal auto rig elements, and just those pink nodes down below here. That's the moment where I add a little bit of something extra as a small snippet that I just insert. So I'm really just inserting exactly the function as we already talked about into my rig, and I'm good to go. And of course, we want to know how a little spider is being built, right? Same idea. So first of all, that file will be available in the content library for you guys, and it comes with a little like spider model builder, so you can all build your personal dream spider. Yeah, and it relies completely on everything that we've seen so far. We can configure our little spider. We're using tags again, and that's how easily we get all those 8 legs rigged with IK. Great, so far so good. I got everything I wanted. That's already a working rig, but it doesn't really move forward. So that's the moment when we're having those ramps again. We're using these ramps, in this case, really like driven keys. And we're reading from these driven keys just at the right moment, the right motion for each leg. So what I need to do is to have a little bit of an extra in my rig, and that is that extra that you can see, that little function that changes where I'm reading what off. And you see, I just commented something out, and now my spider's jumping instead of walking. But it is, again, a function in your rig. Now we're continuing with like a motion path behavior where the spider is also going a little bit sideways if it's going in a curve. And again, what we're doing, these big function blocks that you're seeing, they're part of your rig, and we're doing exactly the same that I just taught you. Is you create a function, you add it in, you connect it in, you're good to go. Now we're adding collision. In this case, we're adding even 2 little functions, one for the legs, so that the legs move over the ground, and one for the body, so that the body moves a little bit smoother. But the same idea, the same concept, just spread over 3 different nodes. Okay, this is all now nice and good. That's our prototype spider. That's where we explore how the spider works. Of course, we have all the code here. In the end, I might have 100 spiders in worst case, and I need to rig all of them up. So I want to have other peoples to very easily get to the point that they can set up those spiders. How can I do this? So you might think like, yeah, cool, I'm just grabbing those nodes and stuff them in an HDA, I'm done. Maybe not. Think about one thing that we have, and we have the Rigscript node. The Rigscript node is exactly the same as the AutoRig node. It just has one additional input. And what it's doing, it's pretty much creating automatically for you a graph version that is super similar to the same effect as if you would stuff it into an HDA. The advantage of that is that thing is so much faster than putting it all into an HDA. You know why? Because in SOPs, I always need to go in and out of Geo all the time. That is slow. And remember what I said about bringing everything to the viewport, being interactive? That thing is, because it's not an HDA. But we can use it similar to an HDA. So now here I have my prototype spider, and I have my army of baby spiders. They all look a little bit different. And I can just apply now my spider as one node with a few parameters on it. Good, easy, done. I just need to configure them, done. And now I have my one crazy spider that is not just a spider, but also has a face rig for whatever reason. And that can be now just added as additional components on top of that. So we can just continue from there and use it like any other auto rig component and just continue from there. So how does that look now when we actually use it? Here I have my little fat spider. And that spider has been also built. Sorry. It doesn't like, oh no, it does like me. Okay. Built with tags, same idea. I connect in the Rigscript that we just saw, that red thread, one node. I have all these nice parameters, so I can tweak how many steps the spider is taking and how high it is. You can see I have the same functionality as with the other spider. It completely adapted to it and allows me now to procedurally apply the same setup over to as many spiders as I want. And to prove my point that yes, we are procedural, you can add as many legs as you want, in this case 44, to create that little body. And we have, as I said, you can just tweak it to work with what we are having here, and now you can animate away all 44 legs in their glory, but you can also animate on top and you get the terrain adaptation out of it for free. So that brings me close to the end of my talk. So here we can see our little Sea or mountain creature in its natural habitat, still be animatable on top. And I just hope that you, no matter where you feel comfortable on the technical realm, be it more on the side that you just want to set up tags and use auto-regs and combine them, you can already go wild with that. Or be it more on the explorer side that you do want to write a few code snippets. Be creative, use it, don't be afraid. You can do so many things with this now. You can be incredibly creative. So enjoy, and I do hope that I'm going to see a lot of crazy spiders soon. So, yeah. Yes. Oh, I need to keep it.
Any questions? Yes. So, George Home in the back.
Thanks, amazing presentation. So the code to node stuff is really amazing. And you also showed some nodes to code.
Yeah.
Is that an entire Apex graph, regardless of the contents, can be translated to Apex script?
Well, I mean, it needs to be nodes that are in Apex. So any SOP verb is Apex. Any Apex node is available as a function, anything there. But it needs to be, of course, Apex. So it goes from node to code and code to node for Apex contents. So you cannot just say you have a lob content and that's all of a sudden an Apex. That wouldn't work. But any node that you have available in any subgraph, so any custom node that you store, be it just created as nodes or as code, is available right away.
Okay,
Yep.
great. Thank you.
Yeah.
Good? Okay. Next question you have.
Thanks. Yeah, that was amazing. Really cool stuff. I was thinking about the Apex script, which looks amazing. Is there a sort of workflow to fuse your custom Apex script stuff together with the auto-rig components? Some breakpoints or hooks so that you know
Oh, you mean when you have written your little snippet that you can use it as a normal auto-rig component?
Yeah, if you can hook it into like post deformation or only hook it into like certain parts in the rig that the auto-rig components kind of...
The cool thing is, I should have maybe mentioned that as a good point, is like you saw these snippets now. Of course, as soon as you save that component script, like the node itself, the auto-rig node has a section where you can save it to disk. As soon as you save it to disk, you have it in your drop-down available, and it works like any preshipped component. So you can use it everywhere then. Is that the question? No.
More like you have your whole rig graph is like a million nodes, right?
Yeah.
And there is a specific point in your rig.
Yeah.
For example, pre-deformations or whatever. In subs, you would use a null out model, and then you would have an auto null, and then you use that as your sort of breakpoints, bookmarks that you go back to.
Okay.
Is there anything planned in Apex that you can always put it into the right place in the stack of stuff you're doing with the rigs?
I mean, that goes towards the rig scripts. They are keeping the order, the track of order, if you talk about that. Yeah, that's pretty much that.
Okay,
so that's exactly what you mean. So you first start with your given elements, and you want to know that it happens at the right point. That's what rig scripts are for. And it's exactly the same system. It's super similar to a lot of the stuff that you know from HDAs. It's pretty much just without the HDA part because we want it in the viewport. If that makes sense.
Yeah.
Rig scripts are a bit like rig templates, if you want it like that.
Sweet, thank you.
Other questions? Yeah. I knew it.
Hey, fantastic presentation. Yeah, really cool. I guess just from, previously doing a lot of rigging in Houdini, but also with sort of a team of riggers. So anything particular you envisage? Very often you'd kind of like go, hey, I'll do the wing here, you do the spine there, or a bit of that kind of thing. But a lot of interoperability. So it's kind of a couple of questions really. Is there anything in terms of rigging teams that you envisage being special use cases? And then the other thing, I suppose, is like very often, you would be doing some sort of geometric stuff. I know it's slow to do soft things, but, obviously with KineFX, you're going to want to do some sort of thing, intersection stuff or whatever,
So you're thinking in the realm of deformers, if I get you right?
Well, more on the rigs themselves, where you might tend to build little custom sort of sub network things to force kind of quite particular behaviors that you might want to adapt.
Yeah.
That wouldn't necessarily kind of just be limited to joint rotations and sort of solvers that you can kind of mathematically describe.
Okay, so first of all, I'm going to start with team approaches. So I think you should be fairly flexible when it comes to that, because we have already exactly support for first of all, you have those two stages that I mentioned. You have rig build and rig tooling. And you can easily already split it up into one. Let's start with a 2-person scenario, and then we spread out. So you have 2 people, one focusing more on the side of like prototyping new little elements, and the other person can just apply it. The good thing is the other person that applies it needs to be less technical, because you just have the interfaces and you configure it. That's one split point. The other thing is we're talking about these components. A component just represents any kind of functionality. So you are free to split who's responsible for what functionality in whatever way you want. Yeah. So if you want to have a wing person, so to say, and an FBIK person, no problem. They can build their own prototypes. As soon as they save it into the library, they have their tools and the others have it available. So you can save all these components into different files. You can solve all these little subgraphs into different files. So managing that as a team should be fairly streamlined, I think. Should be fairly easy. Yeah. So coming to the geometry question, I'm not entirely sure what you're after, but you can operate on geometry in Apex in various ways. You have, of course, all the verbs available. You have a lot of extra giant functionalities and nodes that help you set up joints available, but you can also still apply any kind of like deformer effects if that's what you're after. You can even have OpenCL snippets in there. We have an OpenCL node, and you can put OpenCL snippets in there if you want to go that far. Completely supported. We're actually doing that on certain nodes. So not sure if I'm really answering your question.
Definitely. Yeah, I guess it's just because obviously currently everything's sort of, because obviously with the controllers and stuff, it's all packed and baked and then just resolved down to a single bit of geometry, right? So someone loads in the geometry and that's the full rig and all but then I guess if it's jumping between a bit of that and then a bit of sort of SOP interaction stuff, then it would have to be more kind of HDAs with that sort of stuff packed into it. I'm just wondering, going between pure Apex
and KineFX.
SOPs, KineFX and other things like that.
Yeah. So we do have a few nodes that allow you to go back and forth. I mean, one of the split points is obviously the part where you prepare your character and where you build your rigs. And the way how we are doing it with like putting like that is also a bit the intent behind there is using tags, using these attributes. I mean, you have all of KineFX available to set up a few attributes and to procedurally create that rig. That skeleton, the guide skeleton that we start with. So we try to push that preparation part to keep it in KineFX and to just have the pure build of that functionality that you want to execute. That's Apex. That's where you have the auto rig nodes. That's one split point. Now you might talk about being in animation and going back and forth between KineFX. We have a few nodes, how you can actually extract your information out, how you can still combine it with KineFX. So you can extract the controls out as a skeleton, do, let's say, for example, retargeting on it, and you can bring that back onto channels. It's fairly granular right now, I have to say those. So I should maybe also say this. We're still in beta. So we're still doing a lot of things, and we still really want to push this further on many fronts.
Fantastic. Yeah, thanks so much.
Okay.
I thought it was done. I thought you're done with this. It's over.
I'm never done.
I've got a question. If is there one thing that sort of rises to the top that you think the riggers out there that are using traditional methods will look at this and be like, "Oh my God, that's it. That's the."
I mean, for me, it's just the fact that I see everything in one place.
Yeah.
It's like no matter if you work with tags or with like the coding snippets, I always hated that, like especially with these like big Uber rigs that you set up with like tons of lines of Python code. You sit there, you write something, you need to open it, takes forever, then you see it. That really slows you down. Here you are in one place, and you just try something and you see it directly. If you're wrong, you know it right away. And it really helps working with it. It feels so much nicer, and it also feels more compartmentalized. So you don't have that massive thing that you're working, and you're working on small chunks, and they're very digestible in a way. And that feels, I like that. And I like the fact that it is procedural and really adapts to your data that come in. That really helps. That's my personal impression, of course.
Cool.
Yeah.
Any other questions? Yeah.
You touched on OpenCL inside of Apex a minute ago, and I'm curious, sort of, to what extent is that being used in the COPS system? Is it Apex systems with OpenCL embedded in it, or is it slightly different?
It's a lot more hidden from you. So to put it that way, so you have the core architecture of Apex in place, but it's not really as accessible as it is. Like rigging and animation is Apex directly on the front. So what you're seeing, those graphs, that is Apex. It's always there. And in COPS, it's much more underneath, and you don't really get to that geometry part that easily. So there is a bit of a difference in how it is being implemented. So we are much more directly on it, and that's what I mean. Like the OpenCL software is there. You can use it right away. You can build your prototype so it works.
And just following on from that, using Vex inside of Apex is kind of an iffy subject, I think.
So that's one of the motivations why we put out Apex Script, because we don't want you to use Vex everywhere. And I mean, Vex is really good when it comes to heavy geometry. That's where it shines. So if you think about your super heavy geometry character, where you want to have like a deformer effect using Vex, that's amazing. Go ahead, be my guest. If you operate just on a few nodes like a skeleton, it's incredibly wasteful. And it also really doesn't make sense, because what you do with Vex is you always shovel everything into geometry and out of geometry. Well, if you're talking about multiplying a few matrices together, that's completely wasteful. That's what Apex Script isn't doing that. Apex Script is Apex. So it is super efficient for all of that stuff. But if you still want to use it, then I would rather think about where it shines on heavy geometry. That's what it's been built for. And Apex script is simply a completely different beast, and we went for the Python syntax simply because Python is so well spread and so many riggers are familiar with Python. Yeah.
Okay, and last question that's tied to that. So would you envision using Vex and Apex kind of hand in hand and jumping between them by invoking some kind of...
You can use it. We actually even have examples of that. So yes, you can create a Vex node in there. But as I said, like I would use it with care and I would really think about it before I put it in. I wouldn't just say like, nah, I like Vex better. That's the wrong approach because you're going to be very sad that your rig is all of a sudden very slow. So, and that's the moment where I would go for Apex script, especially like every time you think about putting something into runtime, aka your rig, think twice about what slows it down. And Vex can do that if you don't use it right.
Okay, perfect. Thank you.
Yeah.
Anyone else? Awesome. Well, thanks very much, Esther.
Thank you.